Okay, so this is the screencast for part 2 of worksheet 12 for alkenes. Let's look at question 1. Most of you got the correct answer, but I'll just go through this question. Which of these molecular formula represent the first 3 members of the alkene family? So you must know, alkene, we started out with ethane, which is C2H4. Remember that the molecular formula, the general formula for alkene is CnH2n. Okay, so we have C2H4 followed by C3H6 followed by C4H8. So the answer is B. And it cannot be any of the other answers. Okay. Question 13. Which one of the following formula represents a compound that is different from the other 3? Okay, so again, to look at this kind of question, first you must look at the main chain. The main chain for A is this, including the CC double bond. So if I were to name this would be but 1-in, 2-methyl but 1-in. Okay, let's look at the other. B, the longest chain that contains the double bond would be this, which is also 2-methyl but 1-in. Let me just write down the numbers so you can see what I mean. Okay, because this is the priority, so I will assign as 1, 2, 3, 4. So this is 2-methyl. Again, this is 1, 2, 3, 4. So 2-methyl but 1-in. Let's look at the last one. Okay, I have it again. 1, 2, 3, 4. Second carbon, 2-methyl but 1-in. Let's look at the last one. Okay, I have two ways of drawing it, but both give me the same result. Now, note that in this case, the double bond is not on the first 2 carbon, regardless of how I count it. Okay, if I count from left to right, 1, 2, 3, 4, it becomes 2-methyl but 2-in. Rather than 2-methyl but 1-in, because if you look at the double bond, this is at the first position, first CC bond, this is the second CC bond, regardless of which way I count it from. Therefore, D is not the same compound. Okay, so this is quite straightforward question. Sometimes we will draw the same thing in different conformation and ask you if they are isomers. Okay, that's another common type of question. So it is very important for you to just observe which is the longest chain, and then from there try and name this compound. Okay, what type of reaction is shown in the equation below? Addition, reduction, neutralization, substitution. Okay, so we see that there's this alkene added to HCl, and we get one compound with this as the substituent. Okay, so what happened is this HCl added across the double bond. So this is an addition reaction. What happened is it is added across the double bond. This is an addition reaction. Some of you wrote that it's neutralization reaction. This is not neutralization. Note that neutralization requires the formation of a salt and water, which is both not formed here. Is it a reduction reaction? Okay, you may think that it's a reduction reaction because you gain 1 hydrogen, right? I think that's what you thought. Yeah, but it's sadly not a reduction. It is an addition reaction. As to how to explain it, if you calculate the oxidation state number of, let's say, the hydrogen here, chlorine here, nothing has changed. So there's no change in the oxidation state number. Therefore, it's not a reduction. Is it a substitution? Now, if it's a substitution reaction, it is A, like HA plus BB gives you HB plus AB. Well, you see that they just kind of switch places, so it's like substitution. One is addition. Addition is one girl plus one boy gives you one couple. Okay, this is addition. What is substitution? Okay, substitution is when one girl who already has a boyfriend, when she meet another man, it became like this. So she substituted this for another thing. Okay, that's substitution. In this case, nothing was substituted for another thing. They just simply add together to form one new thing. So that's an addition reaction. Okay, so question 15. What is the structural formula of the compound formed by the addition of bromine to propene? And they even gave you the formula. So let's draw a propene. C, 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 double bond here. So recall the addition of bromine adds Br2 across the double bond. So how do I draw that? Okay, Br. What happens is one of these bonds will break, this Br bond will break, and in the process we form two new bonds like this. So just look at the options. Which of these resemble this? For this question, the answer is wrong. It should be A. Answer should be A. Did I show that the answer is B? Let me check again. 15. Answer is A. Oh, okay. This is 我自己写错. Okay, so sorry. Okay, but it proved that yes, the answer is A. Okay, let me just again. This is the CH3 group that's here. Okay, then each carbon should have one bromine and the rest is hydrogens. Okay. Next, question 16. Question 16 asks you about the application. Fats and oils dissolve in tetrachloromethane. Few drops of bromine water are added and each mixture is shaken. The table shows the result. Which fat or oil is the highest in polyunsaturates? Polyunsaturates means that there are more than one C-C bond. So they are asking which of them has the most number of C-C double bond. Okay, we call that bromine water. This is reddish brown. And when it reacts with a C-C double bond, this reddish brown color of bromine will start to decolorize, meaning that the color will become lighter and lighter. So of which, we just look at all the color of the mixture, which one is the lightest? And that is vegetable oil, which is colorless. Okay, question 17. Which one of the following correctly describes the properties of both ethene and ethane? A, they are both unsaturated hydrocarbons, which is false. The word unsaturated implies that there is a double bond somewhere in the compound. Okay. B, they both readily decolorize bromine water, which is wrong because only a CC double bond will decolorize bromine water readily. C, they are both readily polymerized. Now, only alkenes undergo addition polymerization. If you recall the reactions of alkane, there's only combustion or free radical substitution. Okay, so there's no polymerization reaction. And so the answer is D. They both burn to give carbon dioxide and water. Actually, the true all organic compounds burn to give carbon dioxide and water. Okay, question 18. Which one of the following is best used to distinguish between samples of ethane and ethene? Lighted spleen. Lighted spleen is test for hydrogen gas. Why are you using it for ethane and ethene? Aqueous barium chloride. I don't know this option. Actually, the only answer is liquid bromine because this is the identifying test for CC double bond. Remember, I asked you to star it. It's the identifying test for CC double bond. So liquid bromine will decolorize if the CC reddish brown, bromine decolorize. Okay, note that this should be done in the absence of sunlight because in the presence of sunlight, bromine can also react with a normal alkane to undergo free radical substitution, which also causes the color to decolorize, though not as fast a rate. If you recall the video that I showed you during class, once I drop one drop of bromine into the alkene solution, the color immediately disappears. Okay, so it's a very fast reaction. Okay, question 19. The diagram shows the structural formula of three compounds. Which statement is correct for all three compounds? A. They decolorize aqueous bromine. So again, when they say decolorize aqueous bromine, we look for the CC double bond. Do they all have CC double bond? There's one here, but there's none for the first cyclobutane. Okay, so that's wrong. B. They undergo similar chemical reactions. For this to occur, they must have the same functional group. Again, the first compound, cyclobutane, does not have the same functional group as the other two. C. They are in the same homologous series, which is also false. They are not in the same homologous series. D. They are isomers of one another. To check whether they are isomers or not, check their molecular formula is the same. C4H8, C4H8, C4H8. So since they have the same molecular formula, and we can, with one look, tell that they have different structural formula, they are isomers of one another. Answer is D. Question 20. The diagram shows how useful products can be obtained by cracking long-chain hydrocarbons. Which two substances could X and Y be? Okay, X is used as a rocket fuel, Y is used to make plastic, and then there's other products. So to make plastics, this is always your short chain alkenes because they undergo addition polymerization. One is used as a rocket fuel. We actually did this before, I think one of the quiz for redox. Hydrogen gas is used as a rocket fuel. So remember that there are three things that's being produced when something undergoes cracking. I can get short chain alkane, as well as hydrogen gas. All these are possible products. So that's why the answer is B. Okay, substance Y should be a alkene, so that it makes your C and D. And then B is because hydrogen is produced. Ethanol is not a product of cracking. Okay, note that we are cracking long chain hydrocarbons. So there's only hydrogen and carbon in the chain for you to crack. Yeah, so you should not get ethanol as a product. So that's it for the screencast for worksheet 12 part 2 on alkenes. Watch the screencast on worksheet 13 on the open-ended questions. Thank you.